We have very valuable speakers, and today I want to start by talking about our association. We have been found. We were our foundation is 2023, and and I am the second chairman after following our founder chairman, and then also we will have Mr. Çağlar. Then he was the founder, and we are doing some studies on energy storage systems. Both global and local companies and supplier companies have come together in our association. Today, within these talks, we have very different application areas and the representatives of different companies coming from different fields. We have 5 speakers, and the first speaker will be Mr. Charkan. He is from Huawei, and he will be talking about the technologies of Huawei in storage area and storage solutions of Huawei. Now, Mr. Çağlar, the floor is yours. Thank you, Mr. Can. My name is Çağkan Gazioğlu. I am the CTO of Huawei company. Our company is in the solar energy sector, and now in the storage sector is active since 10 years. And now I'm going to talk about the product selection in energy selection area. And then I'm going to speak one by one on different items. At Huawei, we are active in the solar energy sector since many years, and we have started to work in solar inverters, and we made a 620 gigawatts product shipment from the start. And in Turkey also we are cooperating in solar inverters. And if we speak about the energy storage area, Huawei made a shipment of 35 gigawatt hours of products in globally, and our Turkish installed power is around 10 megawatts. And with our operation areas, we are doing our technical tests, and as the legislations develop, we are working on our compliance in Turkey, and we are collecting the data relatively. Also, Huawei offers solutions for transformers, and we have solutions from end to end, and also for transformers we have a shipment more than 60 gigawatts, and we have more than 200,000 employees and more than 55% of R&D ratio, and we are active in more than 170 countries. Now I want to go on with the second page, but we need to advance the computer and can we go on with the second page? Thank you. Now I'm going to speak about the energy storage systems and product selection. What are the things to consider while selecting the products for energy selections? Firstly, you need to select the products in line with the application type. In each scenario, you can use an energy storage. You can use it at your home, at your factory, and also it can be in the fields, in solar power plant. It can be wind power plant plus storage. There are different product types designed by the manufacturers, and basically they differ in dimensions and they differ in voltage. But the things that you must consider in the big, I'm talking about the big scale systems here, the part of supporting the grid. So we have the grid forming and frequency, proactive supporting of the frequency and the grid is enabled by technical precautions, and you cannot have it in commercial and home systems, but these products must be preferred for large-scale installations. And other point is the system architecture. So we want a long lifespan product, and system lifespan is required to continue in a healthy way, and the system must be modular as much as possible. We must be able to track each component one by one, and in the future years, if there is a lack of performance in the system, we can intervene to these modules, not the whole system. We can gain back the health of the system, and it is very important for the profitability and the durability of the system. Then the third point is the is the efficiency of the system and managing each component of the system and tracking instantly the energy quantity and being able to charge them are very important items. And the cooling systems of the components and the power conversion systems, battery inverters, the PCS products efficiency, and the efficiency of the transformer that you have selected are very important. And at the end of the day, in a container of the storage that you have installed on the field, how much of it can you fit in the grid? And they all depend to the efficiency of these components. And the fourth item, the most important item for the energy storage system is the security. In all technology, in all brands, each manufacturer has some precautions for their solutions, and the point that everyone has to take into care that these precautions must be focused uh, on these points beforehand, because we are using lithium phosphate cells, and if there's a reaction in here, so if we try to intervene after it starts, can cause some problems that cannot be preventable. So if there is a negativity, if there is something going wrong, it is important to find it out beforehand, and with the early warning systems in our systems, we are able to make to technical interventions timely. Another important point is the one of the reasons why the breakdowns are coming out is the grid integration. Thank you. Now, the grid integration. So the thing that TEH, the grid connection criteria given by TEH, and the equipment that we are placing in the field, and the communication software for them. Now I think it's another presentation. I can go on. Technically, your products must be in line with the compliance criteria for the grid of TEH. If you cannot cover them, your system can go out of the out of operation, and especially if you are active in site services, it won't be able to make the needed charge and discharge. And one of the things that enables that is the software and communication and management, energy management system. And this must be working, this should be working in compliance with the system that you install in the field. And together, together with our partners, we are working on this for the long time. And with the ENS solution that we have integrated completely, we are here. Another important point is the after-sales services. The brand that you have selected must have an organization which is established in here, and the service must be taken from one single point. It's very important. Let's say your battery is bought from one company, and EMS bought from another company, and transformer bought from another company. So based on my personal experience, if you have a breakdown in one component, and when you communicate with the producer of that component, firstly, the approach of that brand is asking if there's a problem with the other brands components, and you will lose time. But if you take the if you buy the whole components from one company, you may gain time. And also your PCS and the battery container compliance is very critical. The management of the energy in your battery, the charge and discharge of this is very important, and protection of the battery of your battery is based on your PCS because it's a connection point, and the fluctuation in the grid must not be reflected to the container, and the negative situations must be seen very instantly, and then also the compliance of these components must be taken into consideration. And finally, the usable capacity. We are installing a container into the field. It has a label on it, and it is written how much energy it can store. But while designing this system, it is very important uh, to to have this very important. So the discharge performance of the cells is very critical. The environment is very important. Cabling is very important, and so based on this, the energy that you can use must be calculated beforehand, and then afterwards you can realize your project, and it is very important for the commissioning of the project. And these were the points that I wanted to point out. If you have some questions, I think it will be at the end of the session. There will be Q&A session, and so we thank to Mr. Chakan. So Mr. Chakan gave us some key points for product selection, and so we will also mention about this at the end of the session with quiz, questions and answers. But the security of these systems, we see different news, different technologies about the security of the systems. We are also interested on this, and also we can share with him these questions about all this. Also, there is a component compliance, and with different you can use different components, but you can get them from single supplier. And he mentioned about the advantages and disadvantages of this. Now we will go on with Euro Power Company with Mr. Refik Şenol Çetin, and they have also an investor network. He is going to make a presentation and share some information. Hello, can you hear me well? Because we are not able to hear each other together with the other presentation on the right side. Hello everyone, my name is Refik Şenol Çetin. I am the Vice General Manager in Europower, and it's been 15 years that I'm working in this company, and we go on with our works in the energy efficiency. And today we are going to give some information about the situation in the world, and I will give you some more information about our products. But I need okay, my presentation pointer. Yeah, it must be in the first slide. Okay. Hello, I go on now. After the completion of the first quarter, you can stay in the first slide, please. Okay, you will switch from there. All right. So after the completion of the first quarter, the international worldwide agency and an embassy first started to be issued, and now we see what is the situation in Turkey, what is the situation in Europe and in the world. And now here the 30% of the world energy resources is being composed of renewable energy, and storage capacity also went on, and this will increase exponentially in the future. Also, the data security is also important. There are important R&D works. Also, recycling. We don't speak about recycling today, but we, as a country, with the new regulations, so we must speed up also on the works on recycling. Of course, the investments in Turkey, they started and they will go on, and we are trying to make new products for all these new legislations and new works. And for storage process, there are some fundamental things that have started, but in order to understand the terminology, for instance, frequency control or peak shaving, and I can also there will be big demand about the frequency control instead of the peak shaving in our domestic market, and also in besides the European markets. And also we have other storage products in different areas, and we will do our applications accordingly. Here, what we see in here, the energy investments that done last year, the solar investment and the storage investments, the total value of them is twice as the nearest one. You can see that this magnitude, and the 30% of the whole energy is provided from renewable energy, and the increase in here is even comparable with the nuclear energy. So if the increase in the R&D investments is very high, but unfortunately within our country we are a little bit behind. And regarding this, within the cooperation of the universities, we have R&D center with the universities, and starting from this year, we have a privatized energy management system that we will put on the market this year. And we know the data in Turkey somewhat more, and the investment started with 7 gigawatts, and so we will see that these investments will reach to 11 gigawatts, and until the 2030, the expected amount in the world is 1,200 gigawatts, and also we see that the capacity value in our country is very low. So regarding the recycling, the legislation must be published as soon as possible, and in 2030 a waste of 4 million is expected, and we need to speed up our works accordingly. And LFP, NMC, NACA, different chemical options are present. These are and we are using different chemicals, and so the lithium until after 2050, the lithium supply will low, and there will be new solutions. Now you can see different LFP, NMC, and NCA materials can be used in different fields, and this can be used in different brands, and some of them, sometimes the safety is important, sometimes price performance is important, and there are some solutions that can be done in a safe manner with some kind of applications. But when they are used together with certified products and tested products, we see that these products can be also effective. Also, the cell types are important. The prismatic cells are much more widely used, or other blade cells or pouch cells are started to be used in big storage systems, but we don't know how will they last. We will see it together. And this cycle number, we see it in many areas. Right now, even though it is not an established figure, there are different figures in different brands. So 10,000 cycles, 11,000 cycles, 12,000 cycles are guaranteed. Some people they reach 4,000, 4,500 cycles, but this cycle must be certified, and there are not so many companies that are certifying this. And degradation graphics must be seen, and the cycle number is much more important. Any data sheet on the cycle number that you see on the data sheet is just a number, but other parameters must be taken into consideration. Energy through output value. At the end of 10 years, the total charging number and on terabyte hours level can be provided by the companies. Maybe you need to see those kind of data, because this battery is 10,000 cycles. Is it 10,000 or not, or it must be or not? It should not be 10,000. It it is written in a specification 10,000, but I don't accept 8,000, for example. This is not logical, and I think we will discuss more on this cycle numbers. What do we do in Europower? And so Europower is a participation of Grishim Electric Group, and so starting from 2009 we are doing production, and with medium voltage, low voltage, high voltage products are being produced by us. Also, we have worked together with Chakram. We have a Sanjian product that we have worked together with them for storage. Is a home product. It had the smart hybrid inverter product, and from the ESS systems, we have transformers that we are producing since 15 years, and we have switch boards, and we are covering the whole AC side of the work. And so double winded transformers, and so for the energy management system. So we together we are working with TH transformer centers, and we are building these transformer centers for them from scratch. And also we have some management systems that we have developed for TH. We have more than 100 systems that we put into operation for TH. So we have an experience of for that, and we have also completed many different projects. We have a solar monitoring and management experience, and we are also supplying many products to TH, and we will put all this together with the storage, and we have placed our own EMS system this year, and so we can have skid systems, concrete, Kirch, and others type transformers are being manufactured in our factories in Ankara, which are placed in 13 different locations, and we have different options for storage. 05C or Turkish needs 1C solutions are being implemented by us. EMS solution of ours. So I want to also make a reference from here. So everything must is supported by AI. So So we are going to speak of the AI supported technologies, but we need to adapt all these products to AI, and we need to have human resources for that, and we need to have an infrastructure for training all these people, and the companies like us and the universities and the associations can work together and reach more people. Because we will need more people for that, and I think that we will be in so much need for that.
Büyük bir
We have a huge gap in information security. Today, everyone is curious about the fire protection because if it catches fire, we may not be able to put it out. And these are big troubles. But communicating with Teyash and the customer, the system is fully open and we need to access it 24/7. And it can be charged and discharged, and we may have huge losses of money. So information security standards were only published 2 or 3 years ago, even in Europe. And now we are adopting these EMS solutions, but this is important for us and for the other practitioners in the field. I would like to talk about the Sun Junior product. Sun Junior is one of the steps that we took as we approach EMS. BMS is the battery management system. The software and hardware was designed by our R&D center. This is for domestic applications, one-phase or three-phase, and it includes the electric board. You can have meter protection, fire protection against leaked voltage, and it can work with multiple computers at the same time. So it's a true all-in-one solution. So currently, with all this, our goal is to have a total storage capacity of 1 gigawatt hour in the next 2 or 3 years. And of course, we will be participating in tenders with our solutions on the storage side and the EMS side. And we aim to reach a capacity of 1 gigawatt hour in 3 years. And in parallel to this, what we want to do is to train the new engineers and the technicians and the people in the process and bring added value to our country in this area as well. Thank you very much. Thank you very much, Rishit Bey. In his presentation, we saw some product promotion and information about the competencies of the product of the company, and the cycle times and the information security were the important highlights. And you are in renewable energy, we need to be careful about information security and fire protection. And now there is a new market emerging for our country, and we cannot still see the risks that may emerge with that. Maybe that may be considered as a new business branch for those who are interested in this industry. And we are talking about an eco-friendly energy system, but we need to be careful about the waste batteries, which may be harmful for the environment. I don't want to talk too much about the cycle time because it's a quite technical issue, but we also need to have some information about the key considerations to take into account when choosing a product. And cycle time is one of those considerations. I would like to leave the floor to Uğur Bey now. I think they have various methods of application and solutions in Turkey and abroad, and he will be providing us some information from the field. I think we can hear you well for now because they have a break in the next door, but I hope you keep the microphone close to you. Hello, I am the founding partner of RAMPRO. We offer solutions on agile integration of storage systems, and we also have R&D and innovation activities. This is my 15th year in the energy industry, and in the last 5 years, we have seen that the organizations outside this industry have been introduced to energy production, and with the storage system in the future, these organizations will meet the concept of energy management. And at this point, the systems that only do storage will not be enough. Today, I will be talking about the applications that licensed storage facilities. We are now developing these products, and we believe this is a market that is set to grow. Our first product was a facility with a capacity of 5 megawatt hours. And this is a facility actually. It has not been connected to the grid. And until it is connected to the grid, we are trying to provide power to this facility, off-grid power. And to do that, we designed a power system. And this facility has a successful EMS infrastructure and can manage the balance of production and consumption. And as of this summer, it will be operational off-grid. But this is not our only goal. After that, when the facility is connected to the grid, we want to get the UPS budget from this storage system. So we will not have a dedicated UPS system. So you can use your storage system as a UPS basically. So the budget for UPS will be allocated to the storage system. So this facility will be protected against power outages. Although this may not help us generate revenues, we have another area of use for these facilities. For example, when you have rooftop PVs, you can sell your surplus energy to the grid, but this comes with additional distribution costs. But instead of giving it to the grid, you store it in your system. You can have additional energy, so you can have passive income. Our second project. We have our own facility. At our facility, we have deficit of energy. Our energy generation is not enough for our facility. And we found out that the TEİAŞ does not have enough capacity for us. We need to build a new infrastructure, and we calculated the costs, and the costs were colossal. And then we decided to work on a rooftop PV system. And this investment will cost the same as the network investment, but we can manage our load and we can solve this problem with the rooftop PVs. Because we need to manage our burden. We need to manage our load. We need to be familiar with the concept of energy management. The additional load comes from the EVs. The load caused by the EVs is becoming a problem for us. And now we have a EMS infrastructure that may help us manage the load that is coming from charging the EVs. Another project we have is as follows. We have solar power plants operating in Greece. We may have a similar problem in this country. This is why I'm sharing this example. This year, we have seen something that we had never seen. We have purchase guarantee for these power plants. Every megawatts have to be purchased, but the network does not allow us to do that. Due to the mistakes in the licensing process, we have problems with line capacity and the changing consumer behaviors and excessive decrease in the consumption at specific periods. We receive instructions via SCADA to cut down our generation. Sometimes we are cut out of the network by the SCADA. Sometimes these losses reach 20% in some grids. This is not just in Greece. We also see the same problem in Western European countries. In Turkey, in recent years, we had similar problems in some of our facilities. As a solution to that, we analyzed our losses. And as a result of this analysis, we we wanted to see how much loss we had and at which times we receive restrictions from SCADA and what kind of a storage system could help us store the excessive production when we are instructed to restrict our generation. Of course, the dimensions of this system would be calculated separately for each facility because each facility is subject to different types of restrictions. And in our analysis, we have seen that the storage systems to cover those losses would be more feasible. Maybe in 6 months, our situation will be significantly improved. What I'm trying to say is we look at the European markets as well. Today, our market is growing on the basis of licensed storage facilities. But when you look at the Netherlands or Belgium, the market is developing in parallel to the solutions to the existing problems. But people really have to be feeling this problem closely so that they can go and actually buy these solutions. I'm trying to raise an awareness in my speech, actually. We have engineering companies, EPC companies that have very good solutions. In our experience last year, when we approached the industry with a solution-based plan, we saw that we were able to develop very good storage systems. So the only solution is not the licensed storage systems. As qualified solution partners, we can approach to industrialists and tell them about these solutions and their needs that they are not aware of. This will help us create a significant segment in the industry, I believe. Thank you very much, Uğur Bey. Uğur Bey gave us a glimpse of the real situation of the field, in the field. Maybe we have these zero energy facilities that do not get any energy from the grid, and when you combine it with the storage systems, you can have more profitable facilities. But of course, you need to make significant efforts in the background during the design phase, and you need to analyze the situation and understand how your solution will impact this existing situation. And you gave us some information about your solutions in Greece. Now I would like to pass the floor to Erman Bey. Could you please tell us about your experience?
Umarım sesim iyi
Thank you
geliyordur.
very much. I hope you
Gerekirse
can hear
bunu
me.
o
I
uygulamalarına
think this
gelecek.
is a challenging
Bununla
session
ilgili
for all of us because we cannot
çözümlemelerini
hear each
birlikte
other,
yapmaya çalışıyoruz şu an.
but we are trying our best.
Birazcık gelir modellerinden bahsedeceğiz aslında.
Actually, I'm going to talk about the revenue models.
Biz dün burada aslında gerçekleştirdiğimiz çalışmalardan bahsettik. Hem
We
Huawei
talked about our
hem de
past
Prototype'da.
projects like
Herkesin
Huawei,
kafasında şu
RMB,
anda
Pro Power.
aklındaki ilk soru
When we talk
finans
about
sistemi üzerindeki.
storage, everyone asks the same question.
Şimdi
How do we generate
burada
income from this?
aslında öncelikle ses biraz tekrar değişti. İyi değil mi aslında? Şu an
Can
sesim
you hear
geliyor
me
mu?
well now?
Dışarıdan duyulabiliyor.
Everyone can hear me?
Şimdi aslında ekonomik değeri, depolamanın
Actually,
ekonomik
the
değeri
economic value of
büyük
storage
farklılıklar gösterebiliyor.
may vary
Bu hani nerede
significantly.
olabiliyor? Aynı marketteki bireysel
How does that
kullanımcıyla
happen? Individual
gelir
users in
modelleri
the
elde
same
edebiliyor.
market can have different revenue
Pazardaki
models.
farklı uygulamalardaki
Different
farklı
applications
gelir
in the same
modelleri elde
market
edebiliriz.
can have
Ya
different
da
revenue
farklı
models.
pazarlardaki farklı
Or
uygulamalarda
same
farklı
applications
gelir
in
modelleri
different markets
oluşturabiliriz.
can have different revenue
Dolayısıyla
models.
aslında bizim depolamadan elde edeceğimiz gelir
Actually,
modeli
the revenue
günün
model
sonunda
for storage
doğru şudur veya o pazarda şunu
can be
uygulamak
different.
gerekir
We
gibi
don't have a
net bir çözüm
one
aslında
size
üretemeyeceğiz.
fits all
Bu
solution.
modellerini ortaya koyup bu gelir
We
modellerini
need
her
to
zaman optimize edeceğimiz aslında bir
have a revenue model
program
but
ve
still
doğru
optimize it
olacak.
for various
Bugün birazcık aslında
situations.
bu gelir modellerinden bahsetmeye çalışacağım.
Today I will be talking about these
Şimdi
revenue models.
tabii herkesin
Of
aslında
course,
sıklıkla konuştuğu biz
everyone
niye enerji depolama
talks
ihtiyaç
about
duyuyoruz?
the same thing. Why do we need energy storage?
Baktığımızda
Basically,
bu nedir? Ticari bir malda teknik üstünlük de olabilir. Evet yani
we
teknik
do
olarak
it to have an upper
üretimde
hand
üstünlüğü olsa da
in a
enerji
technical
depolama
product
diğer tüm enerji
because
üretim
energy
modelleri gibi
storage, as
değerlendirildiğinde
compared to other
teknik
energy
üstünlüğü olduğunda
trading
bazı
models,
yerlerde bahsedemeyiz, bazı
give
yerlerde
will
bahsederiz
give
ama
you an
net bir
upper hand in
teknik
some
üstünlük
situations,
olmadığında
but not
enerji
so
depolamaya
much
sahip
in
olabiliyoruz.
others.
Verimlilik dediğimizde
And
birçok
efficiency.
enerjinin doğası zaten bir cycle'da verimliliğimiz işte %85'ler seviyesinde. Biz aslında depolamayla
In one
en düşük
cycle,
modeli
our
kendimiz
energy
destekliyoruz
efficiency is
veya
85%. With
çevresel
storage,
etkiler
we
diyebiliriz.
lead on
Zaten her depolamadan
efficiency
sorumlu
and
şubemiz aslında bu depolamaların, bataryaların bertaraf edilmesine
environmental
dair
impact.
çözümler de oluşturmamız gerekiyor.
We need to
Dolayısıyla
come up with the
biz bu
solutions
şekilde
about the
bahsedebiliyoruz.
disposal of the
Aslında enerji
batteries that are
depolamanın,
out of
burada önemli
service.
olmasının en büyük
The main
gerekliliği
reason that we are talking
dünyadaki
about energy
bütün
storage
uygulamaların
is
ya
that
da tüm
it
enerji
brings a
transmission
competitive
üretimi
revenue
diğer
model
teknolojilerle
as
baktığımızda
compared
biz
to
genelde
other
depolamayla
technologies.
ama işte bu
With
getir
energy storage,
modunu
we
bilgilendirebiliriz ki
offer a
aslında enerji
competitive revenue
depolamadan
model.
daha fazla bahseder hale geleceğiz ve
And
burada
when
en
we do
çok
that more,
önemlisi de
we will be
aslında
talking about
burada
energy
elde ettiğimiz gelir
storage more.
modellerinin çeşitliliği
And
ve
to
bunun
do
aslında
that,
ne
we
kadar
need
etkili
to
olacağını
have diverse
merak
revenue
etmektedir.
models and make it more competitive.
Şimdi temel uygulama alanlarından birazcık bahsedersek aslında
Let me tell you about the main
genelde dört
application
ana alana
areas.
bölebiliyoruz burada.
There are
Birisi
mainly
teknik
four
aksamıydı.
application areas:
Buna en
power
fazla gelir
quality,
orada. Burada
frequency,
power'ı
and voltage
geniş miktarda
control.
kişiler doldurabiliyorlar.
I believe
Dolayısıyla
we have some
en ön
participants
sırada
from transmission operators,
destekleyecek bir model.
so
Ve
they may
tabii ki de
support
burada
me as well.
beraber
Frequency and voltage
depolamanın
control
en güçlü
are
olduğu
the
ve aslında gelir
strongest
elde etmesinin
parts of energy storage,
Diğerlerine
and
göre farklılaştığı alanlardan bir tanesi.
they have a better potential to generate revenues and reliability.
Ciddi bir arz
With
güvenini
energy
tarafında güçlükler
storage,
yaşıyoruz.
you will have a better energy reliability, supply reliability,
Kullanımın optimize edilmesini
and
sağlıyor. İşte körteil ettiğimiz
you
enerji
can
miktarını
optimize
azaltıyor.
the use, you can reduce the
Sonrasında
amount of
arbitraj
curtailed
yine en
energy.
çok konuştuğumuz
And the last
konulardan
one
bir
is the
tanesi. Arbitraj
arbitrage.
imkanını önemli oranda
You
arttırmayı
can
sağlıyor.
increase the potential of
Dolayısıyla burada
arbitrage
hani
by a significant
piyasaları bu
rate.
açıdan baktığımızda
When we look at the
aslında
markets from this
temelde
perspective,
iki
basically
piyasa
we
olarak
see
daha
two
net bir şekilde
markets.
konuşabiliriz. Birincisi yer hizmetler,
The
öbür
first one
diğer
is
tarafta ise
the site
temel elektrik gün
services,
öncesi, gün içi piyasalarımız olarak
and the other one
konumlandırabiliriz.
is the basic
Şimdi yer
electricity
hizmetlere
supply,
baktığımızda
daytime
yer
and
hizmetler
end
gelirlerimizin
of day
aslında enerji
services.
depomada önemli bir pay elde
These site
ettiğini bu
services
örneklerden de görüyoruz.
may have a significant share in
Şöyle
the
bir durum
energy
var.
business. We see that from the global
Enerji
examples.
depolarının
But there's
çökme
one thing
içerisindeki
here.
payı arttıkça
As the
yer
share of
hizmetlerdeki
energy storage
verimliliğinin düşmesi
increases
çok
in the
doğal bir
network,
döngü olarak kendi
our
kendini
revenue
gösterecektir.
from site
Ama bir
services will
yandan
naturally go down.
hem yenilenebilir
But
santrallerin şebeke içerisindeki artması hem de enerji talebinin
as the
artmasıyla
renewable
birlikte
power
aslında yer
plants
hizmetler
have a bigger
kapasitesi
share in the
artmayacak.
energy mix, the capacity
Dolayısıyla
of site
evet
services will
bir fiyat
also go
dalgalarının
up.
bir düşüş olması
So,
halinde toplam
although the unit
market fiyatının
prices may
aslında
go
çok
down, the
düşmeyeceğini
total
görebiliriz.
market
Ama evet birim
price
fiyatta yan
will
hizmetlerde
not go down
enerji depolarının
significantly.
artışıyla birlikte bir
Yes, with
birim
ancillary
fiyatın düşeceğini
services,
ve önümüzde duran
the unit
büyük
prices
partilerden birisi
will
olan
go
yenilenebilir
down with
piyasalarında
energy
da düşeceğini,
storage. We know that
dolayısıyla
from the UK
Türkiye'deki enerji
market.
piyasalarında da aynı durumun
The same
yaşanacağını
will
söyleyebiliriz.
happen in the Turkish market.
İkincisi aslında arbitraj.
The second one is the arbitrage.
Ee, Enerji arbitrajının karlılığının genel olarak geçmişte farklı
The
elektrik
profitability
piyasalarında yıldan yıla
of
%25'e yakın oranında
energy
değiştiğini görüyoruz. Yani dolayısıyla
arbitrage has recently changed by
karlılık yaratması
25%.
rağmen %25 gibi.
So,
Aslında
although
bu
energy
oranda
arbitrage
yüzde farklılık gösteren de bir
is
alan olarak görüyoruz.
profitable, the profits have changed by
Dolayısıyla enerji
25%.
arbitrajında
So, in energy arbitrage,
aslında evet bir karlılığımız var
we have
ama aynı
profitability,
zamanda belli
yes,
riskleri de bir
but
arada
it also
barındırmakta.
comes with some financial
Sanki
risks.
son günlerde aslında Türkiye'deki elektrik piyasasında yaşadığımız şeylerden de gördüğümüz
We
gibi
have
işte
seen
pazar
this
günü
in
ilk
the recent
saatin
developments in the
elektrik
Turkish
fiyatları aslında
electricity
bir Kasım ayının
market.
içerisinde bayramın yanlısı
During the
bir şekilde
holiday,
bayramın ikinci, üçüncü gününde bile santrallerin durdurulmaya başlanması
the power
önümüzdeki
plants
dönemlerde
came to a stop
arbitrajda
on the
hareketlenme
second and
imkanlarının
third day of the
arttığını
holiday.
gösteriyor. Bu da
This
doğal
shows
olarak
us that there
aynı
is a
olduğunu
bigger potential
söyleyebiliriz.
for energy
Şimdi
arbitrage
burada bir
in the future, and we can
daha
say the
bahsetmek
same thing
istiyorum.
for global
Aslında
markets as well. I would
Türkiye'deki
like to
enerji
tell you about a
depolarında bir kere
concept
finansal
here.
piyasalar
This is
bu
not just about energy storage.
cannibalization
This is
aslında gelirin
cannibalization,
eksilmesi. Yani dolayısıyla
cannibalization
enerji
of
depolamaların
revenue.
depolamaların artmasıyla birlikte evet
With the
yıllık miktarı
increasing
çoğalttığında bizim
storage
aslında çürüme
capacity,
yaş diyoruz. Yani o
we will
elektriğin
be
miktarı
eating away at some of our
birim miktarı
revenues,
düşmesi
and the unit per unit
o
profitability will
dolayısıyla
naturally go
yer
down.
hizmetler piyasasında oyuncu arttıkça,
So as
gelirdeki
we have
depolama miktarı arttıkça
more players in the
arbitrajdaki
storage
aslında
market, the revenues
karlılık gibi
will
bir
go down,
önümüzde
and the
çok net bir şekilde var.
offset between arbitrage
Ama
and
bunun
the
aslında
market
tersinde de bir
prices
kavram
will go
gelişiyor.
up. But
Gelirin
there is another
aslında
concept
farklı
that emerges
noktalarında
as well.
olması.
Revenue being
Dolayısıyla
collected
burada
by
biz
different
aslında
markets.
enerji depolamayla belki de
With
diğer
energy storage,
enerji üretim veya diğer aslında enerji sistemindeki kaynaklarda elde etmemizin çok zor olduğu bir
we can have
avantajı elde
an
etmiş oluyoruz.
advantage
Çok
that
fazla marketten
is
aynı
difficult
anda
to
oyuncu
get
bulabiliyoruz.
at
Bunu nasıl
energy
yapabiliyoruz?
resources. We can have multiple
Birincisi
players at the
bilgileri
same
paralel bir şekilde
market. How
toplayabiliriz.
do we do that? We can collect
Veriler
revenues
kaynaklar çok
in
daha arttıkça
parallel. Unlike other resources,
piyasamızda
we can
kaliteli
use some of the
hızlı bir
storage in the
dengelemede
ancillary services,
arbitrajda
some in
kullanabiliriz.
energy balancing, and
Sıralı
some in
toplayabiliriz. Günün
arbitrage.
bazı
And we
saatlerinde yer
can
hizmetler
collect revenues in order. At sometimes in the day we can offer ancillary services and we can offer arbitrage in other times. We can offer different services. We can offer discharging services at the storage capacity, and we can also create a potential for arbitrage when resolving imbalances in the energy market. This is why storage systems are very strong. We become a player at different markets at the same time. And the projects so far show us one thing. If a storage system is just looking at one source of income,
bizim lifetime cost dediğimiz toplam
our lifetime
gelir
cost
o gelirden daha yüksek olacak hocam.
will be higher than the
Gelir
revenues.
hedefleri yani
So do not just
ömür
focus on
boyunca
one type
bu
of
elektrik
revenue.
depolama sistemimiz sadece yan hizmetlerle
Using the storage system
aslında o
just for
rakipleri
ancillary
desteklemek
services, you are less likely to generate revenue from that system. This is the advantage brought by storage systems. We can be a player in different markets, and when we manage that well,
bizim için
total
önemli bir gelir
collected
aracı.
revenues become an important income for
Dolayısıyla biraz
us.
hocam elektrik piyasalarıyla da bağlayıp buradaki
I will
bir ufak örneğimizden de bahsedebilirim.
also talk about the
Birincisi
electricity
dediğim üzere
markets in this
biz
context.
etkin kullanım
And
sağlıyoruz.
with energy storage, we make effective, efficient use of
Şu an
energy.
gündemde de çok daha yoğun olan toplayıcılık faaliyetleriyle çok daha etkin, verimli kullanabileceğini düşünüyoruz.
I think we can use it more
Biraz önce
effectively with the
vurguladım.
collection
Aslında
activities
bu
in the
hizmetlerin
market
kaynağında aslında bu işin optimizasyonunda bir
because
EMS sistemi yatıyor.
there is an EMS
Dolayısıyla biz farklı
system
marketlerde,
that
farklı
lies at the
pazarlarda
heart of
güçlü olduğumuz
optimization
zaman
of this.
gelişmiş bir
If you
EMS
want to be a
sistemiyle
player in
o
multiple
EMS
markets, you
sisteminin
need to
ne kadar
have an
önemli,
advanced
gelişmiş
EMS
bir
system,
programı
and you need to
gerektiriyorsa
have an advanced
o
controller
EMS
to
sırasında
manage that
olduğu
battery
tüketimden
system. And
satıştan
with the EMS
yüksek
and the
marjları,
controller, you
yüksek
can
gelir,
have
yüksek kar oranları
high profitability
sağlayabileceğimizi
rates and
düşünüyorum.
high levels of revenue in your storage systems.
Ama her pazardaki işte orta ölçekli oyuncunun
But a
sektörde
medium
kalması
scale player
birincisi boyuttan, ikincisi de aslında
cannot
yapmış olan
do it
yatırımlardan dolayı
on their
çok
own
kolay değil.
due to the size
Dolayısıyla
of the
oyuncuların
projects and the
bulunması
costs.
bu gelir modelini
So players have to create this model with different structures.
toplayıcılık çıkıyor.
And that
Toplayıcılık
structure
tek bir
is the
şekilde
that partner would be the
mevcut
collectors.
depolamaları santraller hem de müstakil depolamaları aslında önümüzdeki dönem yönetiminde hem ticaret hem
Collectors
kamuya
will play an important role in the management of individual storage facilities and
bir hem
larger
kurumsallaşması bizim için
connected
aslında farklı
storage
modelleri de
facilities
yaratıyor.
because
Hem
having bigger
yatırımcı
dimensions will
hem de
bring
aslında daha etkin
newer
bir yönetim bizim
revenue
için
models for us
buradaki
with the
karları
collectors, and
arttıracaklarını
better
düşünüyorum.
store energy management
Dolayısıyla
system will mean
aslında bu sene
higher
hem
income and
depolama
profitability for
implementasyonu
us.
hem toplayıcılık
And
faaliyetlerinin
with
başlaması
more storage
bizim için
capacity
gerçekten
and with
tebrik
the emerging
edilen
collection
söyleyebilirim.
activities will bring us
Toplayıcılık ve
new
depolama
revenue
birbirini
models.
besleyen çok iki temel
Collection
unsur olarak
and energy
önümüzde
management
çıktığını
will be
söyleyebilirim.
two main components
Burada
of this
son
model.
olarak bir
And finally,
kısa şeyle kapatmak
I would like
istiyorum.
to close with one remark.
Önümüzdeki 5 senemiz ne yapmalıyız?
What should we do in the
Birincisi
next
her
5
oyuncu
years?
bence önündeki
First of all, I
farklı
believe every
aslında
player
görevler olacak.
will
Bizim
have different roles to play.
gerçekleştirmemiz gereken farklı çalışmalar olacak.
We will
Mesela
have to work on various
şu an
projects.
görüyoruz işte ekipman yani depolama sağlayıcılarından
We see that
birincisi işte scale'in büyümesi, öbür tarafta
storage
know-how'in
suppliers will
gelişmesi,
see an
teknolojinin
increased
kolaylaşması,
scale, and
yapay
R&D
zeka
activities will also
bizim
continue.
operatörleri veya fabrikörlerin
Transmission
tarafından
operators or
şebekenin bu
distribution
şekilde
operators
tasarlanması ve şebekenin buna uygun şekilde yönetilmesi için bir
can
altyapı geliştirilmesi gerekiyor.
develop an infrastructure
Ve
so
bu
that
süreçte aslında
the
bizim hani
network
burada
can
daha
run on
fazla
this
bu
model.
işin yatırımcısı olduğunu
And
düşünerek
since
daha
we
fazla
are the
yatırım vermek
investors of
bazında
this industry, what should we
belki
do?
temel
We
kelime
need
var
to
burada.
look at
Birincisi
two
denememiz
different,
gerekiyor.
two basic concepts.
Enerji depolama
Trial. We first need to
deneyimlenerek aslında
test
farklı gelir
energy
modelleri
storage.
kullanacak
Only by
deneyim
testing we
yapılıyor
can
ve bu deneyimler
create
aslında
new revenue models.
çevrimiçi
And we
olması
need to
gerekiyor.
start testing today and
Sürecin
create
Türkiye'de
these
biz
revenue
3
models
farklı proje
today.
bitirdik. 3
We have
farklı
completed
projede
3
3
different
farklı
projects in Turkey so
uygulamaları
far,
deneyimledik.
and they
Şunu
were all
söyleyebilirim, bu
different
3 uygulamada
application methods. And in
doğal
all 3 projects, we had
modellerimizi
different
oluşturduk ilk
experiences. We
etapta.
had different models. We redesigned it. We tried to create revenue models.
Birlikte yaptığımız bu uygulamaların sonunda
At
şöyle
the end of
gördük.
these projects that we
Bu
implemented
sefer
with
şöyle bir
Huawei,
gelir modeli
we
var.
saw that there
Projenin
is a
içerisinde
significant revenue model
daha az
here. You can generate a
deneyimlerle
significant
daha
revenue
kolay
here, but
teknoloji
you need to test it and
uygulamalarla
experience it. You
erişime
need to
bir tık
implement it
daha
in the field and see the results. So we need to have a more agile
eğitim teknolojisi
structures.
yaklaştığımız gibi depolama yaklaşarak geliri hemen
We cannot generate revenues if we approach these
oluşturmamız gerekiyor
battery
diyebilirim.
management systems
Çok
or
teşekkür
storage
ediyorum.
systems, just like we did with the conventional energy systems. Thank you very much. Thank you very much for being loud and clear. Actually, we have various themes intertwined here. Maybe we are talking about a situation where the new players will be involved, and it's not just about selling energy. We will also have collection activities and the very own business models of storage systems. So it all starts with a simple concept of selling energy, and now we have a different concept of energy trading where you have to be an expert, and good management is very important. This is why the EMS is very important. Of course, AI, sensors, fluctuation of energy prices, they are also important factors, but in the next 5 years, we can test different methods, and at the end of 5 years, we can have a better established market. But a new player can change the rules of the game. This is how important storage is. Now I would like to leave the floor to Ergün Bey. He will share his own experience, and then we will have a Q&A.
Şu anda nasıl sesim?
Can you hear me now?
Biraz daha ama biraz Erkan Bey'den kopya çektim.
I'm doing what Erman Bey
Biliyorsam ne
did.
mutlu. Erdoğan,
I'm happy if you can hear me.
sistemleri
Erdoğan, HEPRA, Power Systems Director. I have a presentation actually.
açabiliyorsanız.
Can you put it up?
Tamam.
Okay, it's up there.
Biraz şebekeye nasıl değiştireceğim? Tamam. Santrallerin
I will be talking about the network compatibility of storage systems.
zaten değerli katılımcılar birçok
And the distinguished panelists have already covered many issues.
açık gördüğüm tam anlaşılmadığına inandığım
I will be addressing some critical issues that have not been covered enough.
planlamanın yapılmasından, tip testlerinden, simülasyonundan
Of course, the ideation, the design, type testing,
birçok kritik
and commissioning. Throughout these processes, you make many decisions, and these decisions have minor or major impact on your project. But I would like to focus on 2 issues here about the compatibility, compliance with the existing network regulations. And grid farming technology has emerged recently, and I would like to talk about why it is important. The
literatüre geçmiş.
first one is the low voltage ride-through.
Fazla sonrası sisteme katkı olarak değerlendirilen yetenekten bahsedeceğim. İkincisi
The second one is the
kapasitesi.
reactive power capacity. This is a concept that we are all familiar with. But when investing we may overlook some issue that may arise in this area. Low voltage right-through. These are the analysis results for a battery facility. In the upper chart, the blue and red lines show the curves described in the network. X shows the voltage and Y is the failure. So the network regulation describes what kind of failure you have. And it says when you have a failure and voltage goes down to 0.55 pb and it's lasted 150 seconds, so the failure is on the blue line. Or if the failure occurred in a near line and the voltage goes down to 0, then the failure occurs in the area between red and green. And the failures that are out of these areas will not be in the responsibility of our devices. But if the failures occur in these lines, all of our facilities, all of the storage facilities and transformers have to contribute to this failure. Since it is difficult to test this in the field with type testing, using hardware in the loop, and with simulations, you need to verify this ability. Today, we may not be looking at this very carefully, and you make an investment, and 5 years later, when your guarantee expires, when the voltage on the grid is too high, you may have a problem. TEİAŞ may start monitoring these abilities, and if your devices do not have this ability, and your devices or your inverter technology may have to be replaced. So you need to be careful about this. The chart on the bottom shows how the power plant reacted during the failure. The green line shows the failure. The bar voltage went down to 0.1 kbit. The lower chart shows the reaction of the battery facility. During the failure, the active power went down to 0. And after the failure is fixed, the active power goes back to its previous level. And the rule it has to follow is that since the failure is in area 2, it has to stay above the pink level at 0.05% of the active power. If you trip during the failure and fail to follow this rule, you may be subject to sanctions. And there is another issue here. There are 3 expectations. You need to stay in the circuit, and after the failure, your active power has to be quickly recovered. And 3, when the failure is fixed, you need to supply reactive current support at 100% of the active power. These have to be tested during validation, and during commissioning, you need to verify that these settings are correct. And the second issue is the reactive power capacity. In these electricity storage, this is a chart from the regulation on the network compliance of electricity storage systems. This is an advantage of the battery-powered power plants. If it's a solar power plant, it's a 0.90 power factor. Wind power plants have to contribute to the network at 0.95. They have to do this when they are operating at 100% of their capacity. Sometimes people misunderstand this. They say we take down the active power and recover the reactive power. But this is not what the regulation says.
Aktif güç %100'deyken dahi
Even when the active power is at 100%, they expect us to give the same reactive power capacity. And you have PPS, you have the inverter technology, and the reactive reserve that comes with that inverter technology. So you can reduce the number of inverters, and with your AC, you can make it compliant with AC power. If you have 100 AC power, you can have 100 MWA inverter. However, as you know, the grid regulations have been updated in January. In hybrid power plants, there are some updated regulations. When analyzing the hybrid power plants, we were trying to tell our customers that they have to follow the existing regulations for ancillary resources. Now the regulation actually says that the ancillary resources, like the solar power plant, if the main power resource is not working, the ancillary resource has to supply reserve power at 95%. On the left-hand side, you see a wind power plant. Since it's a battery-supported plant, it has to keep a reserve electricity. For example, my capacity is 100 megawatts and my PCM is 100. Then I may fail in the test because I don't have any reactive power. These tests may be performed at maximum input and maximum output. This is how the system operator designs it. At maximum output, since you don't have any room left, you will not be able to provide any reserve energy, and you have to be careful about that. And some people say 50 inverters will be enough. To say that, you need to see how many meters of cables you have, how many transformers you have. There are various parameters. Without knowing these numbers, you cannot talk about the number of inverters. Otherwise, you have to be cautious about these people. It may just give you an idea, but at the end of the day, only when you have the topology, you may not be compatible with the grid.
1 Ocak 2026.
In the near future, January 2026, KAH will label this. This is very vital for grid operator, the grid forming. When we have some rotors at the same frequency, at the same speed, at the same direction, making the turning movement. It's a big mess, and if one unit goes away from this whole group, it is very difficult to speed it up or slow it down. This is called inertia. As the renewables are in the system, we are losing this inertia. This is a big danger for system operators. For this reason, they are talking about the grid forming technology, and they will use this technology for sure. And as the new revenue model, the battery storage systems will be an instrument. So without this kind of inertia, it is not possible to do it. It's a key for the development of renewables, the grid forming technology. We need to talk about very briefly about these curves that you see on the screen. With this technology, as the frequency goes up, or in contrary, if it goes down, the electricity storage facility decides where to move. It can switch between modes of supplying or demanding, and this creates a virtual inertia. And this is it is something which is experienced in England in a serious manner, and it is needed to be used in our country, and it will be preferred also in Turkey. And while doing our investments today, we need to take care if there is this ability or not. On the above graphic, you see in a battery facility, so you see what happens if there is the grid forming or not. I'm not able to read it very well, but from here, but the red curve fetch frequency response where there's no grid feature. You see the lowering of the frequency. The green one is reacting within 300 milliseconds, and you see the frequency. And the blue one is a 1 second reaction. Rates of change of frequency, rock of reaction changes, and the frequency goes down. And also we talk about the reactive power reserve. Normally our reactive reserve, if it is not compliant, the system operator notified us to the EPDK, and if we take care our TCS capacity, inverter capacities in our investments, the reactive power reserve can be a revenue model for us. We estimate it like this. And thanks for listening to me. Thanks for your patience. If you have some questions, we can take it. We thank also to Mr. Erdi. So we are at the end of our talks. In order to use time wisely, we can take your questions. Then we plan to complete the session. Are there any questions from the audience? There are no audience. It's already 12 o'clock. We are at the end of our time. Thanks to Mr. Ali also. So you gave us information about your expertise. You shared with us your experience about the grid infrastructure. And now we will have a flag ceremony. Then we will have a collective photograph together. And also I would like to thank the audience for listening to us. Thank you. people joining when we start. There's so much noise, but I hope that you can hear me well. We will try to speak aloud. So, Mr. Edip, if you can give us more information about this sound thing. Today, we will be speaking about the local components incentives in energy power plants with storage function. We have very valuable participants, Professor Dr. Kamil Çağatay, Bayındır, Barış Arıcı, Cem Balkan, and so they are here with us, and I would like to say welcome all. So regarding the energy storage, there has been, as we did many panels on energy storage, we spoke about the developments in the sector and the problems in the sector. We mentioned about the legislation, etc. And now we now already have the legislation. We have the licenses. Also, the projects are being approved, and now works are being done in the fields. And in 2025, we will see the installations, and it will increase by 2026, 2027. But today, we will speak about the local components. It's a different topic today. When we speak about the energy storage system, we have three main components: battery package, inverter, and energy production system. And battery pack can be also divided into pieces: container, cooling system, and so today's etc. And today's participants, they will speak about us the batteries and inverters, and I also be speaking about EMS also. And the local production, of course, they have very serious difficulties. Also, we will listen to them. But besides that, within the world, there is a tariff process that started with Trump. As a matter of fact, there are advantages and disadvantages and the risks that may be brought for our country. And for this reason, I think that we are in the right position to speak about the local production. Local producers, they had important concerns for the competition from the east. And now I want to start with Mr. Fatih. Now, our first question is to you. As Astor, as a local production, you made very important steps. I know it very well. It has been an aggressive growth, but it was a success. And in many areas of energy sectors, you have investments. So I want to take your thoughts about what is domestic production, what are advantages, risks, and disadvantages. Please let's evaluate it under the light of the new developments, and also what Astor thinks about the energy storage. Thanks so much. Also I would like to thank to the participants for being here. As our professor indicated, Astor has passed more than 40 years, and very seriously in the final years, it has a growth, an aggressive growth, but also it is based on R&D and based on its past, and hope that we will be in better situation not only in our country, also in abroad, and also we will continue to represent our country also abroad. Also, we will represent Turkish labor, Turkish workers, and Astor's perspective tells us that we did not start all this newly. We did make many preparations. What is the local product? We need to understand it very well. So regarding the local product, Ministry of industry is giving those certificates, but of course you can buy those products from abroad and you can nationalize that product, and then they get the certificate. And if it is a product made locally by 51%, you can get this kind of certificate. And since we have a growth based on imports, this is natural, and the government now is controlling in a higher manner, and the government is working on issuing these certificates with much more strict rules. And but of course, let's speak about the transformers. And we are buying this raw material of silk starch from abroad inside the transformer. But even though you buy this product from abroad, you have a design. You are doing a research and development process, and by competing with foreign companies you can reach to a conclusion, you can get results. And based on the local product issue, the policies, as the moderator indicated, Trump, for example, each evening he's speaking about all these issues and all over the world, because the countries, they started to see that if we are not able to make our production on our own side with our own know-how, we may have difficulties in the future. For this reason, we have some certain incentive mechanisms, and these are coming also from a list. So within the list, there's the inverter. And when we see the inverter within this list of incentives, and based on our experience, and also for regarding the AC DC conversion of the energy is in the agenda, and the transformer also has so much importance, we started to think if we can manufacture a local transformer. And as a company which is traded in the stock exchange, we have announced that we are going to produce these transformers, and as completely off-grid, also by using our central inverter and by using also foreign inverter, we will test these transformers, and we will test them in May and June, and it's around 1000 volts, 1400 volt type products. And we had 10 megawatt hour and instant to 10 megawatt power structure is also operated. We will control the batteries that we have bought from abroad, and we will control the BMS systems of the batteries, and the PCS and the inverters that we have manufactured also will be controlled by us. Also, we have the solar energy power plant in our roof, and also we have the wind power plant, and we will try to get our own energy daily. Then afterwards we will decide if we are going to be integrated to the distribution company or to the organized industrial zone. So it is very probable that we will get integrated, but with the localization of these products, and also with the lowering of initial investment costs, a factory with 50 or 60 persons. So already the electricity prices are already known, and we will start our own sun power plants, and we will support it with the local inverters and with the local PCS. And for this reason, our state and government are giving incentives for local components. They are planning to have an incentive mechanism for factories, for homes, or for other investments, but these are not certain at this point, but if we sum up, what is a local product? Local product is something, as it happens in transformer, we are trying also to produce the central inverter. We have prototypes. We are not able to get the AGBTs from local market, but we are getting them from abroad. But in the future, so each country, of course, cannot make all the components, but we will make advances in the future, and we will be in a better position. Sorry if I was maybe quite long. Sorry for that, but thank you. It was not so long. It's okay. While listening you, I tried to take some small notes. As I understood, Astor plans an investment at the side of inverter. You pass through a certain R&D process, and as the technology selection, you are using central inverter topology. You have selected this one, and besides that, you are going to install a microgrid in the factory. Now I'm going to ask about all this, but now I want to continue with other speakers. At the end, we will have a quiz session. I will make questions at the end. And okay, thank you. Now I will go on with Mr. Barish. We started with the inverter. For energy storage, we have the package, inverter, EMS, battery, and we have the energy management system. So the cell investments, energy, when we talk about the energy storage, we are talking about the cell investments, but inverter is an important part of that. Mr. Fatih mentioned about this to us, but now let's speak about the cell. The REAP Battery Product Director, Mr. Barish, is with us. Mr. Barish, this battery ecosystem, this technology ecosystem, what is that? What's going on? What happens over there? And what does the REAP battery does on this issue? What are your plans on this area? Of course, it's a pleasure for me. So you say cell, but it's not like this. But we are a group that is investing. I cannot go on and make it with the. Can I change the slides? So the YEO group is more than 20 years. We have completed more than 30 projects, and we are working in more than 30 countries. And so it's a big group. So because we are active in different fields of activity, and sorry for that. So if you see basically the keys in hand projects, and we have the biogas, hydroelectric plants besides the solar and wind plants. Also, we are also producing lead batteries. Also, we are a company that is doing its own energy investments. We have projects in Romania and in Italy. Is over 1,000 gigawatts investments are being done. It's an investor, and so of course working together with the startups that are developing technologies. And besides all of this, we are using these activities, and also we are also offering all these services. Both we are using and offering, and now we are now in cooperation with Great Power, which is one of the biggest battery manufacturers in the world. Is the Great Power is already in your appliances for many years, and so we are now working in the grid level, also industrial level products will be produced under this cooperation with them. So why do we need this kind of incentive? This is very important. So let's think about the investors. So the storage and the wind and solar and wind is the biggest market for us. And the requirements, if you look to the requirements of the markets, the investors are doing some feasibility about doing or not doing those investments. They have difficulties about defining that feasibility. But for this reason, we need some local support for that. And so we need to also regulations plus supply chain for that. As Mr. Fatih mentioned over that, PCS, storage and energy management systems, feeding them, all of them, we need to develop the technology, and we need to be able to also transfer the technology to the world. This may seem only local for Turkey, but when you make production in here, as a matter of fact, Turkey cannot be your sole market. You must be feeding the products also all around the world. You need to compete with China. We are following these developments coming from America in the final days. Of course, we have cooperation and we have good we need human resources, and we need infrastructure on world standards. And for this reason, we need an ecosystem. We cannot do it alone. So we cannot buy a production line from China, and when you try to sell these products in here, you cannot compete, because you need to create a value. You need to add some value. If you look this value chain, so we want to make investments, and so we have a structure that supports the startups. And the most important components that may help for the localization is the cell technology, is the heart of the batteries, lithium, phosphate, NFC, also TOG that is producing cars in Turkey. We need to feed all this. Also, this cell planning is within our investment plan. We have we are in a critical position regarding the cell production. But you need to have also the raw material. You need to provide that raw material. Then you must be in a position to write down that recipe, and you need a big investment, big and research infrastructure for that. We are a little bit behind as Turkey. Then you have the cell and the battery. Then you need to have the management system, performance, security. All these are requirements for a storage system. We are at an important point regarding the localization. But together with great power from the products coming from China, we are now using BMS for sending them to Europe and to the world market. And when we European EMS and Turkish products can be sent all over the world, and we continue to do the R&D in a much more productive, together with AI that really using the AI and getting some significant data from that process. But if you look to this general situation, there is a mechanical components. There are some mechanical components that we need. So cooling systems, the carrier systems, and then fire, HSE, safety systems, thermal management are very important, and we are making great effort. And also we are trying to increase the production capacity, and we are trying to expand their production. We want to expand the production capacity of local manufacturers, and we need to develop the suppliers. and on the customer side, incentives must be supported in order to develop them, and we need an improved form of these drafts, and in order to have much more feasible investment. So if you look to sales, so if you don't have a local sale, you cannot have a local incentive. We need some changes while doing a solar plant. So you have the PTF, BMS, and you put solar and wind and many manufacturers creating a whole package, creating an accessible product, and you need to also support them financially. These local packages can reach to different points all around the world, and we need to support them also with the Exim Bank incentives. But what we do, in contrary, we buy a wind turbine from Germany. We are putting German PCS, and then we are bringing the German financing to Turkish investors. We need to change this kind of flow, and we have to make many things. And also, you make the local product, but you need to certify them. That's another cost. You cannot manage it. It is very critical also to support all this. And you have the product. We don't see the battery as the final product. It's see it as the service, because it degrades within this lifespan, and we need to manage it in order to optimize its performance. Also, you have some hardware over there, and also you need software. You need ESCOM models with, and especially I spoke on this slide a lot, but I will go faster. Afterwards, when you go to ESCOM models, the number of the points that you are going to support are so much. On the investor side, they are valued. When they are priced, the local manufacturer motivated because of the existing market. And if the state also gives incentives to this, the production process now is faster, and in the end, this chain must go on. It is very important. With us, with YEO Group, we are developing cathode product, EMS development, cyber security development, and developing also the membrane and the small scale integration, all of this. And so with the know-how, with the most important producers, is being transferred to Europe, and we continue to create this kind of ecosystem within our structure. And so our factory in Tuzla will start with 5 gigawatts capacity. In the second stage, we will go on with the cell production, and we have made an application to the ministry, and in the same package. So the secondary use and also recycling facility also is planned. This is the final view of our factory in Istanbul. If you see it, basically the grid level applications can be seen here. Also, there are some commercial and industrial applications, and we have also the home applications. And thanks for your attention. Thank you. Thanks, Mr. Barish. We got many important information from you. Also, we had good news regarding your investment plans, because our country needs those investments. Also, on the sales side, you will have good news in the near future. Now, our panel's team are the incentives. We talk about incentives here. When you start a facility, so there are investment incentives for the ones that are building facilities. Then when you install a, a solar plant or wind plant, you are incentivized for using the local components, and there are some incentives for local components, and there's a drive for that. And the cell was 55% BMS, 10% inverter, 30%, and EMS 10% incentivized. And the ministry now got some feedback also regarding this draft. There are different views also. With the decision of the President of the Republic office, there are some incentives. So there we need to have much more information about that. There are different views about these drafts, and we hope that all this will be clarified in the future days. Now we can go with Mr. Jam. Mr. Jam, I will have two questions to you. We have started with the incentives, but Netox, Watox has a new investment in future days. There will be the opening of the factory. And first of all, can you give us some little information about this? And also, can you give us a little bit more information about the incentives? For at YECA side, what kind of incentives? And with the solar plants, with storage, what kind of incentives do we have? Thanks a lot. Hello, everyone. My name is Cem Balkan. I'm the Associate General Manager at Vatox on growth. I want to speak about our Vatox and the local inverter production site. What is Vatox? What is the what? It's a unification of watt and ox words. It's about watt and the power of an ox. And Endox Innovators partner ethical and Persify companies are our groups companies, and within Vatox we have a local inverter factory in Ankara. And we started the serial production, but we did not make the official opening ceremony. But we started already the serial production, and we have a 330 kilowatts power local inverter is being produced in our factory, 330 kilowatts, and our target in here, and so to make the 330 kilowatts inverter production is we have a covered area of 2,500 square meters. Then after we want to make a R&D center for the power production, and in line with our this perspective, we want to also produce the PCS, and we are employing 50 employees in our factory. Our capacity is around 1 gigawatts, and we are targeting to reach 3 gigawatts. And our R&D center and production center, we will increase the number of our employees by twice or three times, and we want to contribute to the energy of Turkey. And here our product technically is a product that we cooperate with Huawei, 330 kilowatts local inverter, and it has similar features with the inverters that are present in the market. It's the highest level highest powered inverter in the market. It's a local product. Also, the investors can get the best results in an optimized manner from this local product. And from another point, so also I want to mention about the incentives. these local inverters, what kind of advantages can offer these local investors? If this can, there are some incentive mechanisms of our government for power plants, and so we started to schedule production. Also, we are about to get the local product certificate, and so and also we are working on enabling the investors to use this kind of products.
Kilowatt saat başına bir teşvik var. Bu
$0.23 is offered for every kilowatt hours of energy that is produced with local inverters. So when investors use this incentive, the cost of inverter will be paid by the government, and according to our analysis, they will have additional returns of 10–11%. When we look at the solar power projects, as the moderator mentioned, the directive has been approved by the ministry. Final details are yet to be clarified, but under today's conditions, $0.4 of advantage or incentive is offered per every kilowatt hours. This incentive will be in effect for 1 year. So it gives you a return of investments on your inverters, and you will have additional returns of 10–15%. This is all I have to say, dear moderator. Thank you very much, Jim. This was a quick round, actually. We can have an interactive session with the questions. So if you have any questions, we can hear them and have our second round with your questions. So we would like to get your questions if you have any. Otherwise, I will be asking some questions. I would like to add something. Our booth, Watok's booth, is in Hall 7. At our booth, you can actually see 2 inverters that have been manufactured at our facilities in Turkey. The session next door is about to start, so there will be some noise, interference. So if you have any questions, we can hear them now. So no questions so far. Let me ask a few questions. Fatih Bey, the first question is for you. Well, it's not quite pleasant to have 2 sessions colliding, but we will try to be quick. In your investments, you have a central inverter. Why do you choose the central inverter architecture instead of steering inverters? Well, the main reason is when you use it with PCS, there are 2 issues. When you use solar power plants or wind power plants, a central inverter can directly convert DC into AC. And in the PCS, since it is close to the batteries, the central inverter gives you more advantage. Those who work with renewables would know this. In some projects, central inverters may have disadvantages, and in others, it may give you advantages. When we start using central inverters, we start using power electronics. We are aiming to reach $1 billion as of next year, And hopefully we will be working with electronics more, and in the future we may work with steering electronics as well, steering inverters as well. The key here is finding locally manufactured inverters. Even if today's conditions, only 5% of investments go to central inverters, it will give you an opportunity to work with power electronics. So at Astor, when making this decision, our goal was to get the opportunity to work on power electronics and do some R&D work on that. Since this is on our agenda, the investments in renewables and the incentives on renewables, we decided to use an inverter. And for the first stage, we decided to use central inverters, but that does not mean we will use other types of inverters in the future. Our first products are yet to come. The prototypes are expected very soon. 1000 watts DC, 400 watts AC are currently available. In the future, we will be able to have something that is compatible with a network of 694 AC. Because in most facilities, they use 400 megawatts, and it is compatible with many transformers. If it was 690 megawatts, you would have to invest in a new transformer. Of course, we will work with R&D to ensure that compatibility, but it doesn't make sense to spend so much investment on these issues. Recently, we had this discussion with a manufacturer of PVs abroad. I should be able to convert your solar panels output into AC and DC and use it in my facility. And they said they can produce solar panels with a capacity of 100,000 megawatts. So you start with small components to build the whole thing, because there is a specific efficiency of solar panels and it's been improved today. So it's the same thing with the inverters as well. To do an R&D, you first need to work with a smaller scale, and then you identify the problems and analyze them and improve your product. Local manufacturers like Botox, RIP Battery, or us is very important, because you should not be dependent on foreign resources. You should be able to find local solutions. I will give you an example of a transformer. We sold a power transformer of 690 MWA. If we wouldn't do that, they would have to buy it from a different country and they would have to spend a lot of money on imports. And Astor made a significant contribution with this local production, both in terms of financial costs and time of delivery. And we also contributed to employment, market. And I would like to thank the professors for contributing to our R&D activities. And I think you also asked the question about the off-grid systems. I think the lunchtime is approaching, so the participants are leaving. Maybe we can discuss that at a different session, because I'm really curious to hear about that as well. Because since it's lunch break, the participants are taking off, so we need to wrap up quickly. If you have any contributions, Barış Bey or Cem Bey, we would like to hear them, and then we would wrap the session up. Well, whatever happens, Astor always wins. There is the PVS and the batteries, but Astor is a value on its own. You asked a question about central inverters that are locally manufactured, and we need to do some R&D work to increase the local contribution to these projects. And CML segment in the world is growing, but in our region, there is a significant investment to supply the components locally that are indispensable for our projects. So we believe everything that is being done in these R&D projects are very important. Otherwise, we would have to import those PVS from China or Germany. And to ensure interoperability, we need to have a library of PVS and BMS. Having the technology locally manufactured helps us build that library, and investors feel safer about their investments, and they get faster return of investment. That's also very important. Although the cells will be imported from the eastern countries, locally manufactured PVS and PMS systems will make the life of investors easier. So we will continue to invest on those technologies. And we would like to hear your final remarks as well, Barış Bey. I would like to add a few things about what Fatih Bey mentioned, because he brought up something very important, the importance of R&D, the importance of national R&D activities. Our company has been involved in this industry for 15 years. We are among the founders of power electronics in Turkey, and we have a significant pool of knowledge. And we are using that knowledge in our batch manufacturing efforts and R&D activities. Here, Astor, RIP, Yeon, through their local R&D activities, all contribute to energy independency of our country. And I would like to thank everyone for their participation. Cembe, thank you very much. Well, it has been quite challenging because the two sessions are happening at the same time. I would like to thank you very much for joining us by implementing R&D activities and local production activities. These companies are contributing to our country's efforts in solar energy, and we would like to thank them very much. Hello, everyone. The title of the session is focused on the advancements in energy and the new products. And in order we are gathered to recognize the work that is being done to make Turkey one of the leading countries in the energy industry. You may have many questions. I am working at the Ministry of Energy, and if you have any questions, we can address them as well. But let's first hear our panelists, and after each presentation, we can get the questions related to that presentation. The first panelist is Faysal Başçı. He will be talking about their work about the graphene material. Hello, my name is Faysal Başçı. I work at Nanography Nanotechnology company. I'm one of the founding partners. Today, we are talking about graphene supercapacitors and graphene-based storage technologies. Can you hear me now? Let me start over. My name is Faysal Başçı. I work at Nanography Nanotechnology company. I'm the founding partner. Today we are talking about graphene-based storage technologies and graphene supercapacitors. Before talking about this issue, let's talk about what graphene is, why it is so important for us and for our country. Now, graphene is a carbon-based material. Basically speaking, it is a section of a diamond that is only as thick as an atom, and it bears all the properties of a diamond. As you know, diamond is the best thermal conductor, and it has very high electrical conductivity. It's a transparent material, and it's very robust, very durable. And this may sound interesting for you. And when you think about that, it is the most elastic material that is known. According to lab tests, as compared to copper, it has higher current bearing capacity that is 100 to 1,000 times higher than copper. And it is higher strength than steel, that is 100 to 1,000 times higher. To give a qualitative example, we use aluminum in coolers, and the thermal conductivity of aluminum is 150 watts per Kelvin. And diamond has 2,400 to 4,000 watts per Kelvin. So it can be used in cooling applications as well. One of the interesting things about graphene is the surface area. Graphene is a two-dimensional material, and every dimension is only as thick as an atom. It's quite lightweight. To give a qualitative example, when 1 gram of graphene is approximately used to cover an area of 400 to 500 square meters. So you can turn that into a sheet and use it to coat an area of 400 to 500 square meters. Therefore, it is thanks to graphene if we can use EVs and use lithium-ion batteries on EVs. We owe that to graphene and nanotubes. You can think of graphene as a A4 size paper. It's a very thin parchment, and nanotube is that paper folded into a tube. That is a nanotube. The electrical batteries and the lithium-ion batteries that we use today have a very high capacity because of this critical technology of graphene and nanotubes, because you increase the surface area and have a better capacity, and it is more thermally more stable, and it can be charged and discharged more quickly. As we said, graphene is a two-dimensional material, and it's a miraculous material. I will talk about the negative aspects of the material as well, but since the topic of this session is supercapacitors and storage, we need to talk about that as well. As you know, batteries are actually composed of an anode, a cathode, and the lithium part. The lithium ion or nickel or LFL batteries that we use today have basically the same methodology. One anode, one cathode, and one electrolyte. In the battery technology, basically, to store energy, you use a chemical process. If your battery is not charged, via ion migration and chemical modification, you get energy and dispose of the battery when it's no longer usable. When recharging the battery, you have some chemical reactions happening inside. There are some reactions in the electrolyte. There is constant migration between the anode and the cathode side of the battery. And due to this migration, the physical structure of the anode and the cathode change. This is why batteries have a specific service life. And these deformations may be higher when you put the batteries under stress. This is why when you use the batteries out of the recommended regime, the anode and the cathode cannot recover its former form when charging and discharging, and therefore its capacity is decreased. Another storage technology is the supercapacitor. The supercapacitor, or the former condensator, is not a new technology. It's a very old technology, and it is used a lot in electronics. Those who deal with electronics would know this. When we talk about condensators and supercapacitors, we talk about nanofarads, microfarads. Until 10 years ago or 15 years ago, that was the situation. Until about 15 years ago, supercapacitors came into our lives. And when that happened, we started talking about the level of farads. So we were talking about microfarads, and now we're talking about farads. The capacity was increased by 1,000 times with the same volume with the use of supercapacitors. What do the supercapacitors do? A supercapacitor does not have a very different structure than a battery. It has two metal sheets like the anode and the cathode, and there is a dielectric. This may be made of fluid, but there is one difference. In a supercapacitor, there is no ion migration. The supercapacitor stores the energy in electrostatic form. So when you apply a voltage on it, the electrons are polarized, and the energy is stored in electrostatic form. The energy storage capacity of a supercapacitor is determined by several factors. Imagine this. My two hands are electrodes. The electric in between. If it is shorter, naturally the electrons on the electrodes and the electric interaction distance is reduced, so you have higher capacity. So if the electrodes are close to each other, the supercapacitor will have a higher capacity. Secondly, if you have a wider distance between the electrodes, the capacity will be increased as well. About 15 to 20 years ago, the supercapacitors came into our lives by reducing this distance between the electrodes. Maybe you have seen the conventional condensators. It was only 500, 600 microns, this distance. With the nanotechnology, with nanomicrons, the distance between the two electrodes was decreased to nanometers from micrometers. So the capacity was increased by 1,000 times. So instead of talking in microfarads or millifarads, we started talking in farads. And about 10 years ago, the graphene entered our lives in volumes. We have been manufacturing graphene for about 15 years, and globally it has been manufactured for 20 years. The cost of graphene was reduced to reasonable levels about 15 years ago, and it started being used in supercapacitors. And when that happened, something else happened as well. We started increasing the surface area. From a few square meters, we were able to go to several hundred square meters. So with graphene supercapacitors, we were able to use several thousand farads instead of several millifarads. What is the capacity of the supercapacitor? Any guesses? This supercapacitor has a capacity of 100,000 farads. So about 25 years ago, when I was at university, if someone brought up this idea, I would laugh at them. I would think it was impossible. But with this super capacitor, we can increase the capacity to 100,000 farads using supercapacitor. This is equal to 102 watt-hours of energy storage. So 75 ampere hours of cells. This is done thanks to the graphene. Because with normal aluminum, the surface area is 1 square meter. But on 1 square meter of aluminum, you can cover it with 1 gram of graphene. The surface area goes up to 400 square meters. If you use 2 grams, the capacity surface area goes up to 800 square meters. The critical thing here is, since we are storing energy in electrostatic form, and since we charge and recharge through the movement of electrons, you can eliminate all chemical and physical problems. As I mentioned earlier, in a conventional battery, you basically dissolve one electron and deposit it on another electron. You migrate ions, and then you call it back. When calling it back, you love the idea that that may hit those holes on this side. But if you do it too fast, they will not go into the holes, and in time, those holes will turn into bigger holes. If you disassemble the diodes on these lead batteries that we used in the past, you would see that you would see those holes. So when you do that, you don't have any physical migration between the electrodes. This is why the life of the supercapacitor is quite long, because there is no chemical reaction. Since there is no chemical reaction, there is no problem of heating. So when charging and discharging supercapacitors, you actually don't see any heating due to the dielectric inside. If there will be any heating, it will be because of the material that you use in the electrodes. It's because of the resistance of that material, maybe aluminum. It has an internal resistance that may cause heating. And this gives you significant advantages. The biggest advantages, for one thing, the service life is an advantage. For example, maybe you have seen in the exhibition, there are electric batteries that have a life of 2,000 to 6,000 cycles. In supercapacitors, currently, we have guarantees for more than 20,000 cycles. Today, we brought a sample. This cell, we performed some lab tests on this. The escalated life of this is 116,000 cycles. So if you charge it once or twice a day, it's about 300 years. That's quite a long service life. Another thing is the biggest advantage of electrostatic storage. You can charge and recharge the battery very quickly. This supercapacitor is 3,000 farads. It's a battery of 1200 mAh. If it were a conventional LFP battery, the manufacturer would recommend 1 ampere or 1.5 ampere of charging rate. You can charge this cell with 15 amperes and discharge it with 15 amperes. So in this cell, you can go from 10% to 95% in about 10 minutes, in 2.5 minutes. That's something quite revolutionary. We were always talking about having this in vehicles, charging vehicles in 2 or 3 minutes. This technology will allow us to do that.
Now here we can say that we talked about the positive sides of this kind of technology, but what are the negative sides? Now let's talk about that. Let's talk about the energy concentration. LFP 160 and 200 watts is the concentration, and classic graphene supercapacitors, it is around 130 watts. We can store 130 watts per kilogram. So for unit weight, energy concentration is lower for supercapacitors, and ownership costs. If we evaluate on the cell basis, graphene supercapacitors are more expensive. It's 2 times than the normal ones, but electronic ones. So you buy for 100 liras. So, but for supercapacitors, you pay 150 liras. This is the capex, and if you consider the opex, so the ownership of the supercapacitor is more lower, because if you use the LFP within 8 or 10 years, you need to renew the LFP, but here you can use it for 30, 40, 50 years. So that also we can talk about the operation. So the classic lithium-based technologies, you need to keep between the 10 degrees and 40 degrees the cells. If not, since it's a chemical reaction, so you lose the lifespan of the cell, or you lose the total productivity. But capacitors are electrostatic storage, so you can use the industrial temperature range minus 40 and you need plus 50. You don't need a special air conditioning, and ownership cost is much more profitable as a total operational cost. There's another point. So while we are studying these technologies, another thing that we have studied on is the hybrids, where the hybrid cells, the so we worked how to increase the unit capacity per weight. I have another sample here. This is a pouch cell or prismatic type cell. It's a supercapacitor, but this is a hybrid one. What you see in here, the energy concentration, density 215 watts per kilogram is better than LFPs. So it has all the advantages of others. It can reach to 10G of charging, fast charging and discharging. The sample that you see in here, in nominal point, you can charge it with 6C even, but if you need it, you can charge it in 6 minutes. So you can reach from 10% to 95%. And after 95%, you need to go slow. This is well for all the battery technologies. What is good here, as you can see, this is flexible. So you cannot do it for lithium polymer or other types. So if it is not possible, this is the good side of this battery. You don't lose anything. Even in the laboratory, we have pierced out of this. There's no problem. So they continue to operate. For hybrid technologies, so there is a little bit chemical reaction in difference with the others too. But the good side is over LFP regarding the energy concentration. So here I can place a comma and go back a little bit. I want to go back to graphene. So I mentioned before the graphene surface area is around 450 square meters. The reason for that is that graphene, if you look theoretically to graphene, the surface area 200 is around 2,600 square meters. But of course these are accumulated, and what you reach, and the graphene surface area is around 400 and 450 square meters. And we have a factory in Ankara with producing the graphene, and we are one of the countries that is doing serial production for graphene, and in the world. This is a very big advantage for nanographene. The 95% of our sales have been abroad. In Turkey it is used very less, but more than half of the companies within the Forbes 500 is our customers. They are buying this product, and we started 2 years ago to study. So we wanted to enlarge the surface area of graphene. So now let's think graphene is an A4 page, and the graphene is composed of carbon. Since it is only carbon, in order to bond something to this, you need to open the carbon atoms. But did you ever hear a union of with diamond? You cannot connect to diamond copper or iron, etc. And graphene is something like this. You cannot create a composition with other materials. And METO, together with the American Energy Department, we have been able to create some holes on the graphene, and the connection between the two is very tight, and for this reason the diamond is very hard element. But we have an A4, but it's a A4 with holes on it, just like a sieve. And thanks to these holes, physically you can penetrate other materials inside these holes. Or when you open up these holes, the one end of the carbon atoms over there are free, and other materials, just like oxygen, iron, and copper, and can be tied to this product. And so I'm going to show you a material. So this is the board graphene or polysuper graphene. This material, there's some holes on it. It's just like the coal powder, but since the graphene parts, they don't have an A4 size, isn't nanometric particles. This holy graphene is 16 months ago we started to produce and sell, and the whole of it has been sold to abroad. And before the religious festivity, the gram price of this was $1,700. And what is the price of graphene? Do you know? The kilo price for graphene is $300–400. And 10 years ago, when we started to produce the graphene in Turkey, the gram price was $500–600. Today we are selling per kilogram at this price. So, and this price came from $3,000 to $1,700, this macro product. And we also lowered the price of this product. So because the 3 years capacity, 3 years production capacity was completely sold before the festivity, and at the end of the scaling, we started to produce started the mass production. And after the festivity period, now we have reduced the price, and then polygraphene price per gram is $10,000. What is this feature? Its surface area is 970 square meters. So let's think about what we said about the super capacitor. We went up from 400 square meters to 900 square meters. Potentially, this super capacitor capacity can go up by two times or 2.5 times. So this 130 watts per kilogram. So this can be 300–400 watts per kilogram. And this means, I hope that we will do it next year per kilogram. When you see 300–400 watts per kilogram, then you are competing with lithium polymer, not with LFP or lithium. It's a 10C capacity. We are talking about 10C capacity charging and discharging, and we are talking about a lifespan of 20,000 cycles. Is a revolutionary thing for energy storage. And normally, something like this. So, if you would like to make it in Turkey, so the graphene, if we would want to make a graphene supercapacitor in Turkey, they would ask us, where will you find the graphene? No? If you try to do it in Greece, they will ask you, from where will you find the graphene? But there's a big opportunity in Turkey because this question's answer has an answer, because Turkey is one of the biggest graphene producers in the world. For this reason, we think that this technology is a big opportunity for our country, and within this trade wars happening today, this can bring us into a very strategic position. Now I can stop a little bit and I can leave the floor to the other speaker. Thank you. Thank you, Mr. Tansel. So I think this has been very productive. Now, dear guests, do you have any question to Mr. Faisal? Now the teacher asks to the students, asks if you have questions. If nobody answers, this means that nobody understood nothing or everyone understood everything very well. Here, we don't see the some questions. I feel that everyone understood it very well. So I'm an old person. I remember the days where there were blockouts and we were buying candles and then when for the during the blockages we were burning candles, and also the prime minister of that time, Demirel, was a sympathetic person, and then they are asking to Demirel that we are buying some energy from Greece, that we are not at good terms with Greece. But he says that 6 months we are buying from them and 6 months they are buying from us. So, but in Turkey, the installed energy power in February 2025, we have an installed power of 118 gigawatts, and we are actively using the 40-45 gigawatts of this power actively. With the increase of charge stations, the increase of EV vehicles, there's a need for more energy, but we need 724 operating stations and plants that are going on with the base load capacity. And so for this reason, for us in Turkey, inevitably the imported coal and natural gas need is going up, and we need to buy from abroad. But instead of that, the storage. So from we don't trust so much to sun and wind. We don't make our programs based on this too. We are taking patients at the base load, and in order to, with the thanks to, we are planning to have storage systems of 33 gigawatts, and this is planned by our ministry. And this 33 megawatts is planned, but still there is no installation on that. But when this happens, our need for imports of coal and natural gas will lower. So with the storage, so you store in the daytime and you can feed it during the night time. and this will open some doors to us, and this will enable us to have better base load. Now we can go on with Mr. Ercüment Doğan. I think you can hear me. Very dear guests, I say hello to everyone with respect. Now today I am one of the founder partners of Thai-based technology company. As Mr. Faisal indicated, there were every element needed, but we as a startup we started to work on the production of capacitors, and one of our partners is Mr. Faisal. But what I want to emphasize in here is nanography, who is founded by Mr. Faisal, and these two companies, so for graphene production and on the electronic side, they are able to supply, and we can do our R&D works together. We have so LND technology and the nano gravel technology started to work together, and then we have the Plan Group Energy, and these three companies came together and created the Thai-based technology, and in January 2025 we have started our activities as a startup. All the technology background is based on graphene and polygraphene. Mr. Faisal explained it to you, but I want to show also some photographs of them. So these are on the upper side you can see the photographs of the graphenes. Then in the below there's a drawing and where you can see carbon atoms, and I will try to describe what we are trying to do. So the graphene, as you know, is a material which is produced at some certain levels around the world, but graphene with holes is an interesting one that has a great potential, and Mr. Faisal has been modest, but the holy graphene production number one around the world is our company, and where these products can be used. As you can see on the graphics, starting from the energy storage and the water treatment, you can use the polygraphene, and we wanted to put into action this potential for the energy storage, and both the Ministry of Energy and the private sector. So since there are very big potential for the investments in this area, we are targeting this kind of potential. The graphene supercapacitor is something which is produced and consumed around the world. In 2025, its market share is 4.5 billion US dollars, and after 2030, we foresee that it will be just like 20 billion dollars, and its use areas so is because this is used less than lithium product is because the graphene production. If you don't have the graphene production, you can not use it for the cell. So it is very important that we have a local producer here of the graphene, and also the holy graphene is also solely produced in here, and lithium-based products, the supplier chain, China is dominated by China by 70%. Of course, the mass production of China is very important, is very powerful. China is over there, and lithium-based products are so much enforced to the market, and so you see the NL storage systems also in this pair. But what is interesting in here, even though lithium technology is so widespread in China, of course, China started also to use the graphene-based capacitors and storage system. But as much as the graphene, so it is in direct relation with the quantity of production of graphene. So you can by 40. There's a so for the graphene supercapacitors you pay more, but for the others you pay less, of course. But this creates a very serious potential for Turkey, and we cannot foresee what happens with the trade war between the China and USA, and also maybe it is possible that there may be some changes in trade routes. So for this reason, it is very important that a country can produce this kind of products itself locally is very important, even though for global market it is $20 billion trade volume is foreseen. If we can make a mass production of this with local and national resources, we believe that this kind of production will be made in Turkey, and especially this will happen in Islamic countries, in African market, and all around the world. I want to make a benchmark of battery technologies, so you can see technical benchmark of the lithium batteries and of the graphene batteries, but it is good to tell it in figures. So in the so this supercapacitor in here is 125 watt per hour capacity. If you produce the graphene with graphene, this is like this, but if you use the holy graphene, the capacity can go up 3 times more, and it will go up over the lithium ion batteries, and it can operate between -40 plus 85 plus 80, 85 degrees, so you don't need any air conditioning. So this kind of cells can be placed in any place, in any container. You don't need any air conditioning. It can operate everywhere, in the mountain, in the sand, and everywhere it can be operated. And the life cycle, we have some laboratory tests. We have seen 116,000 life cycles theoretically. We don't have any problem by guaranteeing 20,000 cycles as the manufacturer, but the accreditation and after certification accreditation of this, so we will have the possibility to guarantee higher cycles. And this causes that if you buy an EV today, and if you apply the battery with this kind of capacitor, so the battery pack will go on all the time, even though you may change the car. Or for home type systems, it can be used for lifelong, and so it is very valuable and important for capex. It creates a great advantage. And besides that, what I want to emphasize that, so of course you have seen the fair. Here everyone is talking about the off-grid systems. The roof panels, lithium-ion storage systems are mentioned in this fair, but we are also speaking among us. We see that everyone has an EV one way or another, and the electric prices went up, and home type electricity they went up. Together with the solar panel, you can have auto storage system in your home, but theoretically, but nobody thinks to place in their house a storage system, the lithium ion packages. You see the reason for that. There is a fire and explosion risk for this system. Nobody takes this kind of risk. You can have this kind of installation in your garden, but for your house, it is not possible to use this kind of battery. This is a risk and risk perception of the people. But with our capacity, with our electrostatic system, since it is an electrostatic system, we don't have the risk of explosion. You can use it everywhere within your house. And regarding this, in the next 6 months and 1 year, we will introduce our products, and we have an advantageous products in our hand. And this was something that I wanted to emphasize. And our next graphic, so a comparison of supercapacitor technologies, traditional conventional supercapacitor, so which are used in electric circuits. Then in the second column you see the graphene supercapacitors, and the third one the holygraphene capacitor. Now if you compare three of them, especially on the holygraphene side, there is a big potential. We have an expectation of over 500 watt hour capacity. We have R&D process on this. Another point, the holygraphene, its price went down dramatically, and it's a much more rentable and profitable product. And for this reason, so we have some we are so we need to shift our production to holygraphene instead of importing graphene from abroad. What are the utilization areas of graphene supercapacitors? You can use in each field of our lives, for example, consumer electronics for smartphones, computers. This kind of capacitors can be used in computers, power banks, and UPS systems, micro mobility, e-scooter, and e-bicycle, etc. Mobility applications. So still, supercapacitors are being used already in EVs, in buses, also they have started to use also in trucks, and we can also use it in tractors. We have a startup also in our country, and they are also converting the existing tractors to electric tractors. And so the conversion of all of this, it is possible with supercapacitor battery, but the big problem with lithium batteries is the longer charging time, and because of the charging after a certain time you need to change these LFP batteries. But supercapacitor is a solution, and because it's a high charging capacity and it has a longer lifespan, and we will see that this will be used much more intensively. Another one is the home type storage systems from 5 kilowatts to 100 kilowatts, and also there's a network support systems, so it can help the system. Of course, it's over 1 megawatt energy storage systems are the areas that can be used. And finally, there are military applications, and it's the wide use of application, laser weapons, electromagnetic cannons. So, but since we are in a civil area, we don't speak a lot about these issues.
These are the pictures of the capacitors that I showed you earlier. The purple capacitors on the left, these tiny ones, these are like alternate batteries. On the right-hand side, you see the cell that we were bending earlier. This is the larger cell. You can combine them in different orientations and use it on a scooter. You can put 3 of these and create 16,000 mAh of capacity. In the beginning, power bank, UPS systems, and home type storage systems were our areas of focus. We focus on B2C operation. After working on projects in this area, we will be rolling it out to the other areas as well. I think this is the end. This is all I have to say on behalf of TIDES, and I would like to leave the floor to Tahir Bey. I would like to thank you very much for the presentation, Ercüment Bey. Any questions for Ercüment Bey? Please. Now, as compared to lithium-ion batteries, it has many advantages. But you talked about the advantages. You didn't mention the advantages in terms of budget and costs. Well, when you import these products, the prices are slightly higher than lithium-ion batteries and LFP batteries. And there is the freight costs and the custom costs, custom clearance costs. So, as compared to $100 investment on LFP batteries, you need to invest $150 into this battery. And when you manufacture it in Turkey, we perform 2 types of analysis of that process. And when you have mass production, the cost per cell is 40 megawatt hours. When you buy it as a package, it is like 90 megawatt hours. And it is 15% more cost effective than the lithium ion battery. And there is one more advantage. Of this end of service life, you need to dispose of the lithium ion battery, but this one can be used throughout your life. And this shows that the technology companies like us are looking for these solutions. When we start manufacturing these products locally, the capacities allocated by the Ministry of Energy can be met by these systems, and we will not be bleeding money to other countries. And since we have the raw material, and since we will have incentives for mass production, we can manufacture it at more affordable prices. So there is a significant difference between import and buying locally. Buying locally will be 15% more affordable. Thank you. In the past, we used to say Germany is better than us in machinery and many other areas, but now we are better than Germany because people setting up PVs in Turkey are now doing it in Germany, and many EPC companies in Turkey are going to other countries and installing systems. And it's not just 1 or 2 megawatts. They are working with 300, 400 gigawatts, and we are proud of them. So our people are doing it better than other countries now. No, Kenan Demirtaş will take the floor now. Thank you. Kenan Demirtaş from Turkish Electricity Distribution Company. First of all, welcome. I will be talking about the graphene supercapacitors, the local manufacturing efforts, and the advantages of supercapacitors as compared to traditional lithium-ion batteries. These issues have already been covered by other speakers, so I will be talking about how we can use these supercapacitors in the electrical transmission and distribution network. I became aware of this only recently, and I believe it will bring many innovations to the market, and it will improve the balance on the market. I think it is an innovative technology. We have lost your sound. Can you hear me now? And in energy transmission and distribution, this technology may change many things, and we will talk about these changes. First of all, the supercapacitors came into our lives, and which areas of innovation will we see with them? The main areas of change is the change in energy quality parameters. It will ensure coordination of the command and relay, and it will also help with the frequency control, which has a significant volume in the market. Furthermore, since the data flow will be increased in smart networks, and we will see a significant improvement in that area as well. And finally, with the introduction of graphene supercapacitors in the market, the distribution and transmission networks will see a significant change. First of all, with the introduction of supercapacitors, they will be working as a UPS. So the Ministry of Energy and other affiliated organizations will start thinking how to improve the energy efficiency in the supply. And there are various parameters in that process. The first one is the continuity of supply. Recently, there was a power outage, which was an undesirable experience. But with the use of supercapacitors, maybe such power outages will become history. And commercial quality and the marketing is another aspect, and technical quality. And technical quality can be described as powers, as the decrease of voltage, voltage peaks, frequency change. There are many parameters here. And I think this technology will help eliminate all these issues. And the Ministry of Energy emphasizes local production and the support to local production and the improvement of the system in their own agenda. And at our organization, TEDASH, we use batteries in various areas. We particularly use batteries in redressers to supply energy to the relays that protect the command system. And we use them in the command and control. We can also use these supercapacitors in the remote control systems. And we don't use any batteries in any other areas. However, with the introduction and development of supercapacitors, the frequency control can also be affected because we have many regions where we have frequency control. We have very big teams working on frequency control in these regions. And these teams are working to balance the frequency at all times. They make hourly estimates. And when making these estimates, they check the markets, the pre-day and post-day markets. So they analyze the whole process on 24-hour basis. At the peak hours, approximately 52,000 megawatt hours of energy is used in the grid, and to ensure continuous supply of 52,000 megawatts of energy, we had the distribution operators had to keep 352 megawatts of energy as a reserve to ensure the balance between the consumption and generation of energy. Imagine this, you have a dam and a nearby energy production center. You need to keep 352 megawatts of reserve to ensure the balance. In the project so far, the dams would operate unnecessarily, so the water would flow just to create a reserve of energy that may be needed. But if we can, but I believe supercapacitors can have a significant role to play. And these batteries may come into service when needed, and we may not need to have reserve energy anymore. And how do we use 352 megawatts of energy to balance the grid? When balancing the load, in normal conditions, we use primary frequency control and secondary frequency control. The primary frequency control is done at the operation point of alternators. So if they're operating at 70 and if there's a surplus of energy, then it goes down. If there's a higher energy demand, it goes up, and it tries to balance. And if the reserve is used up, a plant that's operating in idle mode, producing 352 megawatts of energy, comes into service and covers the gap. But if you can create a battery switch site, you will be able to cover the deficit energy, and this 352 megawatts of energy will be available for use. And one of the future developments in transformers. In the past, there would be a huge load on the transformers during peak hours, and during other times, these transformers would just be in idle mode. But now, with the battery technologies, we will be able to store energy. And after the peak hours, we will have battery systems in all homes, in all households. And this will help us improve the energy quality infrastructure, and that will help us create a very robust infrastructure system. And the use of the transformers may be reversed, because when we have PV systems on rooftops at all households. We may be able to supply energy from the households to the transformers. And of course, with all these developments, the Energy Market Regulation Authority and the Ministry of Energy has started issuing a new license called the solar energy systems with storage. To have these systems, you need to have battery management systems, and you also need to ensure a balance between the smart network, smart grid parameters. And this will also help us create the smart grid infrastructure, and that will create a significant flow of data. And that data can be handled and processed by artificial intelligence. And finally, when batteries are used in all households, we will have a new distribution grid and a new transmission line. And only then we can have households or homes that supply their own energy, or even sell energy to other homes or companies. And when we have these battery systems in all households, the frequency control can be monitored in real time, and that can be done and the frequency control may become unnecessary because these battery systems will ensure the security of supply, because we will have the same voltage, we will not have any decrease in voltage, and we will have a high quality energy supply. But for now, as it seems, to ensure frequency control, we need to have very big switch sites. This is the end of my presentation. Thank you very much for your attention. Can the supercapacitors eliminate the need for condensators in the future? I'm talking about the reactive energy. Yes, but that would be very expensive. But as I mentioned earlier, if we have battery storage systems in all homes, and if we have the UPS systems, you don't need that. Any other questions? And then I would like to pass the floor to İsa Boğaz from KDT Energy. My name is İsa Boğaz. My colleagues already covered many issues. I will try to keep it very short. And I would like to talk about issues that haven't been covered so far. Generally speaking, supercapacitor is a new technology, but we are not very unfamiliar to it. We have been using it in many systems, but the actual progress has happened in the use of areas. The specifications now include more areas for the use of supercapacitors, because there are some systems where you need to replace the batteries very frequently, and now we want to use supercapacitors for these systems. And why did that happen? What is the difference between supercapacitors and conventional batteries? There is the service life, the number of, there is the cycle time. These are the highlights. But on the other side, one of the differences is that we are talking about energy density. And there's also the power density. Power density refers to the amount of current that you can draw instantly. It works, the supercapacitors work with very low resistance, so it can give you very high current. It can give a high current to the grid and eliminate the current fluctuations. And we already use these supercapacitors in UPS, but not as a battery. The UPS has a battery, but on the electric circuit, you have a supercapacitor. That is to eliminate overload on the system, so the excessive load is taken up by the supercapacitor. And the durability. With higher durability, you can use the material in the defense and aerospace industry. Faisal Bey mentioned that the system has been available for 15 years. But 15 years ago, when I heard about this system, it was used in the trains to recover energy. Because when the train comes to stop, there is a regenerative production. You store that energy in the supercapacitor, and when restarting the train, you get that energy from the supercapacitor. And now we will be talking about its use in the EV technology, because we are already using it in the start and stop procedures in the EVs. Battery is something else. You can see a lot of batteries all over the place, but since we can use supercapacitors instead of batteries, there is that advantage. And due to its long service life, it can be used in medicine, in cardiac applications. These are the main areas of use. Since everyone is focused on storage, we would like to talk about the advantages that it brings for storage. The prices may be higher, but that will be overcome with more local production of these systems. But despite that, you use one system for 6 years and the other for 18 years when you look at the cycle time. So in terms of service life, supercapacitors have a longer service life, and it brings faster return of investment. And a hybrid solution may be an option. Yes, we have the battery technologies, but people are now talking about use of supercapacitors plus battery. For instant charges and recharges, discharges, you can use supercapacitors. So the first supply of energy comes from supercapacitor that will help you save from the service life of the battery. You will prevent heating up of the battery. And Faisal already mentioned this. He said you have a bigger surface area, so cooling is an advantage because heat is the biggest enemy of electricity. Because it has very low resistance, less heating occurs. If you have seen the systems, you see specific problems. For example, you use BMS to prevent heating or ignition. What is the main purpose of BMS? Keeping the battery at a specific level. Supercapacitor has an advantage for that because Faisal Bey said they tested it for 40 Celsius degrees, but it's the ambient temperature. With its own internal temperature, it can even operate at 65 Celsius degrees. Charging and discharging. The biggest disadvantage of supercapacitor is giving out too much current. If you connect the supercapacitor to the system without a circuit, when there is a short circuit or first charging, you can get a very high current instantly, and your electronic circuits may be damaged. That's the only disadvantage. But in hybrid systems, you modify the same system and use supercapacitor in addition to an electric battery. So what else can I say? I try to cover the areas that haven't been brought up. So if you have any questions, I will try to answer them. So any questions for Isabe? I feel like there is a question. No questions, please. How long will it take this? How long will it? So when will the graphene technology penetrate all areas of life? This year we will be launching a commercial product. We have a projection conducted with Tybes, and according to those projections, we will be launching some supercapacitor products this year in Turkey, and mass production will start next year. Currently, we don't have any plans to launch any cells because our manufacturing capacity will only cover the plans that we have. But after those plans are completed, we will be able to supply some supercapacitors to the market. I forgot to mention something. You see, this is a quite flexible material. This is not very easy with the lithium ion, but very easy with this technology. You can create batteries that are flexible or that have different types of geometry. In normal conditions, you cannot have these geometries with the conventional batteries. As you know, these battery packages are built by bringing together the cells at specific dimensions. But in this technology, as I mentioned earlier, you can have batteries in different shapes and geometries. Starting this year, we will be able to use them. I would like to add something to that. I tried to mention this in my presentation. Before the end of this system, power bank systems, UPS systems, and home type storage systems will be created in 5 packages of 5 or packages of 10, and they will be launched. But more scaled up production will happen in the future. We have some plans for the future. For next year, we are talking to the investors, and when we wrap up those negotiations and have the facilities up and running, we will be able to manufacture batteries that will be used in all areas of life. But this year, you will be starting to hear the name of Tybes on some power banks, UPS systems, and home type storage systems. I think that's not. I think they will not be the only types of products that will be available, because some customers are already coming to us to understand whether this can be used on EVs, because there's a significant problem of the batteries on EVs due to the start and stop procedures. So in the future, we will be seeing supercapacitors everywhere where batteries are used. İsa Bey, would you like to add anything? No. No. I would like to thank all the panelists. I would like to turn to the audience. Do you have any other questions? Not only about the supercapacitors, but in other areas like the wind or solar power.
Merhaba öncelikle.
Merhaba. Bir
Soracağım.
hoparlör yaklaştırır mısınız? Uzak tutunca anlaşılmıyor.
Şimdiye kadar
So we have seen in the stand and what we see in the presentation, you start from the small dimension product, power bank, chargers, or factories, but why don't we think about creating a big storage and then with a high power storage sending to TH? Why don't you think to have this kind of system in EPDK? So there's no technology for that, or there's something other impediments. We as EPDK, we have also excellent situation since there are no big batteries. So there is a 33 gigawatts capacity, and this capacity starts from 10 megawatts and until 250 megawatts, and for wind also there has been some excitement, and national real estate also assigned some land, and so you can place one battery, then it goes on with 250 megawatts, but it is not possible technically. It's a good idea, but we want that Turkey is not a dumping place, but we can use it as long as the technology advances. We agree with you, there is no impediment. So it is not, we start from 10 megawatts. It's not 1 megawatt or 1 or 2 kilowatts. It's a big capacity. And EPDK started to work on this, and everything is clear on this field. And we are giving licenses in order to have development in the energy area. And I kindly ask from our friends in the market, people, they know it wrongly, so they must come to the ministry and get the right information from us. So we have our ministry, and our ministry is ready to serve to people, and they are waiting for you, and there's no problem for that. I want to make an addition. So of course, since we are a commercial company, we have a trade commercial strategy. Mr. Kenan also mentioned he is an engineer also working with SEDAŞ. Just he knew us only 1.5 months ago, and so, but another company, this company is a 14-year-old company, and but you just knew this graphene technology right here after 14 years, but to offer a product for the final user is very important. In order, so here there are many, for example, companies, and for storage, there are many foreign companies. Some of them are global companies, some of them are local companies, and to compete with them, it is difficult for us. But even though only one person knows this technology, and even one person gets a power bank in his hand and uses at home and recognizes the difference of that. So, and also our government started to recognize and is aware of the technology. They will start also use in TIH, and only several projects have been accepted this year, but this technology will be in our daily life. But in future years, there will be projects with high quantities. I can take other questions. Are there any questions? I want to add something. Mr. Kenan will tell something. Yes, Mr. Kenan, please keep the microphone a little bit closer. So it's okay now. Regarding the energy, so it was about the storage. So EPDK so started to build these licensed solar energy plants newly. The wind or solar plants. So of course the sun goes up and down, but we need the energy during the nighttime more. And this was a storage idea that at this point came out. So how we can use more this solar energy. So we have a 1 megawatts of solar plant, and it can reach up to 10 megawatts during the summer. But so it can you can just store only 1 hour energy with 1 kilowatts. But thanks to supercapacitor, so with a battery system of 6 or 10 years lifespan, if you can do it, it is not profitable, it's not feasible. So it's a supercapacitor is not like this. You said 300 years. It has a lifespan of 300 years, and this is something. If you have this kind of system, it lasts 300 years. So I can use it for 30 years, and I can leave behind me as a inheritance for 270 years. And it's a big work. It's a great job. And the Ministry of Energy is supporting the local production, and they are shaping the legislation accordingly. And so it means that there is a great deal of job done, and it will have great impact. And also the wind plants would would damaging the environment, but they can also have some problems on the grid. But thanks to battery systems, if there's too much wind, you can store it, or when it is less, it can compensate, and then it can create a balance between demand and supply, and this is very good, and this causes the formation of a much more dynamic grid. These were my words. Thanks to Mr. Kenan. So, dear friends, if you look to the other countries, we mentioned about Germany. So 1 kilowatt is 50 euro cents. is around 21 Turkish liras. But in my house, it's 2.5, 3 liras. So we are so much better than Germany, especially regarding the energy. Our ministry is working 7/24 really, and this is not only the storage. There are other license projects, ECAS, and other things. And if you follow it from the website of DEAŞ, we are offering all these possibilities to all our people. So we say to our people, to the people working in the sector, do it today, not tomorrow. This is our country, and so what we expect from you, okay? We are evaluating all your demands, all your comments. All our friends in the ministry are working on this incessantly. There can be some drawbacks, there can be some problems, we can correct them. So we don't say that this must happen or that must happen this way or that way, but we compensate the deficiencies and we are making corrections. Okay, if there's no other thing, I think so. There's a question. There's one person that wants to make a question. Hello, welcome. First of all, so in our country, this regarding the renewable energy, so this on-grid sites for the personal consumption. So what if our customers don't pay the distribution fee to Enerjisa because the transform is the system that is communicating with the transformers within the city. Of course, if there is a solar plants in the field, the Enerjisa or electric distribution companies, they work hard for them for those plants, but this payoff time is between 4 and 6 years. But for the electric distribution tax, so because of the invoice that are issued to our customers, we are not able to have our projects approved by our customers. So, is it possible that companies just like Enerjisa does not collect this kind of taxes? In Turkey, there's not only Enerjisa, there are 21 different distribution companies. They are applicators. They don't have nothing to do. EPDK decides on that. Of course, distribution fees are very high. In order to overcome, so there's 51Ç, 51C, and 51H, and then also there's another article 51J. We are trying to explain it. I understand you very well. This is really because of the program done by APDK. It's about the cost of electricity. Of course, there is a distribution fee is collected as APDK decides on this. It is not. It wouldn't be right if we say something. Okay, thank you. Thanks a lot to everyone. Thank you.